Great, so this week we're going to be looking at week 11, which is a topic that some of you said you're already doing in geometry anyway. And it's looking at names of different names we can use to describe angles, like complementary, supplementary, names like that. So I'll go through all the different names and then give you guys the notes for the week. So the first two examples are about complementary angles. Complementary angles mean they add up to 90. What does a 90-degree angle look like? Yeah.
This.
Yeah, like a capital L,
Yeah.
right? That's a 90-degree angle, or like a capital T. You know, that's the top and the vertical part of the T make a 90. Yep. And this is the symbol that we use right there to indicate that an angle is a 90. You put like a little kind of square in the corner of the angle. All right. So I know the numbers might look a little bit small up here, but I think you can probably see them better on your notes, maybe. Let's start with this one on the left. What angle is complementary to angle 3? What angle could we add to it that would make an L shape? Nathan?
Sorry, can you say that again?
What angle is complementary to angle 3?
Complementary meaning like.
So complementary means that the angles add up to 90 degrees.
Oh, so you just one?
No, if we took this one and we took that one and we put these two together, they wouldn't add up to 90 degrees.
Oh, okay, so 2 and 3.
2 and 3, yep. So the answer to the first one, that's the symbol for angle in front of the 2. Angles 2 and 3 together are complementary. Yep. They didn't ask, but does anybody see what other 2 angles are complementary here besides 2 and 3? If there are, actually, are there any? No, actually, I take that back. There aren't any. They're supplementary, but not complementary. Next one. It says, which angles are complementary to each other? All right. Anybody see 2 angles in this picture that if you put them together, they would make 90? And I think there's lots of them. Yep.
The 4 and the 5.
Yep, the 4 and the 5. Can somebody give me a different pair besides the 4 and the 5?
2 and 1.
Yep, 2 and 1. Is there anything else? 3 and 4, no. I think that's it. Anybody think they see anything else that would make an L shape? Yeah?
Maybe 6 and 1.
6 and 1? Well, 6 and 1 would make a shape that looks more like this. That's 6 and 1. Is that like an L? No, not quite. It's a little bit bigger. So I think that's it. So that's complementary. Does anybody know the word for angles that add up to 180? So complementary is 90. This is another word. It begins with an S. Supplementary. Yep. So supplementary angles add up to a total of 180. 180 looks like a straight line. So 90 is an L. Think of like 2 L's back to back. You make a straight line, just like that. All right. So how about here? I think we got a lot of them. Can somebody give me a pair of angles that look like they make a straight line? Yep.
3.
Yep. 3 and 4. 2 and 1. Yep. Somebody else give me
7 and 8.
7 and 8. Yep. What else? How about Caleb? Can you give me a pair? Yep, 7 and 6. I would say those are definitely supplementary. What else? I think we have 2 more pairs on each. Yep.
6 and 5.
6 and 5. And let's finish off the bottom one. What other 2 angles? Yep, go Smiley.
8 and 5.
Yep, 8 and 5. And Micah, can you give me another pair at the top that are supplementary?
What was it, 180?
180 means when you put them together, they look like a straight line. So any of the pairs we have so far are all supplementary.
3 and 4.
Yep, so that's the first one. 3 and 4 are supplementary. What else?
Oh, 4 and 1.
Yep, I would say if you put 4 and 1 together, they make a straight line. And can anybody give me the last pair in the top that make a straight line?
3 and 2.
3 and 2. Yep. So those are all the answers for that one. So eight different answers. All right. So that is supplementary. How about on the next page? I'll go to it, but I want to see if people know it first. Angles that are crossed from each other in an X shape. Does anybody know what you call those? Like 1 and 3 in this picture. You're smiling?
Vertical angles.
Yep, those are vertical. So vertical angles are across from each other in an X shape. All right. Which angle is vertical to angle 4? So what angle is across from 4? Bless you. Yeah. 1. That's it. Angle 1 is across from angle 4 in this X shape right there. Are there any other vertical angles in that picture? Nope. I think that's it. Okay, adjacent angles. Adjacent angles just mean angles that are next to each other. That's it, just angles that are right next to each other. Colin, what angle is adjacent to 6? Yep, angle 5 is adjacent because it's right next to it. And what other angle is adjacent to 6? One more. Yep. Yeah. Angle 1. Those are the 2 angles that are adjacent to 6. Could anyone tell me, let's say angle 4. What are the angles that are adjacent to 4? Yep.
3 and 5.
3 and 5. Yep, perfect. Yes. Yeah. 3 and 5. Yep. Okay, so that's adjacent. Next word, congruent. Okay, congruent means that they are exactly the same size angle. Like, if I drew something like this, and then I drew something like this, are the purple angle and the green angle congruent? What do you think?
Oh, wait, yeah.
Yeah. They face different ways, but it doesn't matter which way they face. Congruent just means that they are the same size. So let's start with angle 2. In this picture, what angle is the same size as angle 2? Yeah?
5.
Right. How come angle 5?
Because they're right across from each other.
Right. Any 2 angles that are across from each other in an X shape are the same. And what do you call angles that are across from each other in an X shape? What was the word for that we just went over? Yep. Well, they're congruent because they are vertical angles. Yeah, bless you. Yep, they are vertical angles. Are there any other angles in that picture that are vertical? Again, this is just me asking the question. That's not what they asked. Is there anything else in that picture that's vertical? Yep.
4 and 1.
Yep. Angles 1 and 4 are definitely vertical. Anybody see another pair of vertical angles? Yep.
3 and 6.
3 and 6. Yep. Perfect. Okay, so that's congruent. The next words, they describe the size of an angle. Okay, an acute angle, that is an angle that is less than 90 degrees. Less than 90. So Caleb, what kind of angle is this one?
20.
So the question is this angle acute, right, obtuse, or straight?
Acute.
Yep, this one's acute. Why is it acute?
Huh?
Why?
Small.
Well, why? What makes it small? How small?
90 degrees.
Smaller than 90. Yeah, smaller than 90. Okay. What do we call an angle that's exactly 90? I think that's going to be the next word on the sheet. Yeah.
Right.
That's a right angle. Okay. Right angle is equal to exactly 90. What's this angle?
Right.
Yeah. How do you know it's a right angle?
The square.
Right. When you put that little square there, that means the angle is 90 degrees. Okay. What do we call an angle that's bigger than 90 but less than 180? Yeah.
Obtuse.
That's obtuse. So the angles that are bigger than 90 and you need to add something to that. Less than 180. If it goes bigger than 180, it's not obtuse anymore. There's a different name for that. Okay, how about this one? Acute, right, obtuse, or straight? Yeah, this one's obtuse because it's bigger than an L shape. It's been stretched bigger. And then what do we call two angles when we put them together and they make like a line?
Straight.
Those are called straight angle because when you put them together, they look straight. Here's an example with two separate angles. Like if I did this. There they are separate, the black and the green. Put them together, they make a straight line. That's why it's called a straight angle. So now look at this picture. Acute, right, obtuse, or straight? Yeah. That makes a straight angle. Okay, last two things. So next thing is looking at a protractor and determining the size of an angle. Okay, there's two scales on this protractor. To determine the size of the angle, right, you put your protractor right on the vertex, and then you look at where it intersects the scale. Now, this intersects the scale at two different numbers. What's one number that it intersects at? All right, I would say 110. And what's the other number? 70. So it's on both. How do we know which number it is?
Biggest one.
We just always pick the biggest one? Which one do you think this one is? 110 or 70? Right, this one's the 110. When would we use the 70?
Oh, if it starts at the other side.
Right, if it went on the other side like this, and I asked you, how big is this angle right here? This is 70, but the one that they had in the book was,
It's whatever, if it starts on the left, then it's the bigger, if it starts on the right, then it's the smaller.
yeah, on this particular protractor, if it goes to the left, you're reading the outer scale. If it goes to the right, you're using the inner scale. I don't know if every protractor is like that, but this one is. Okay. So this angle was 110. How about this angle? Looks like it is the same. Yep. So which scale would we read here? The outer numbers or the inner? Yeah, the inner numbers, because we want to answer smaller than 90. How big would you say that is roughly?
75.
Yeah, I'd say it's probably 75. Okay, you wouldn't want to say 100 and whatever that is, 105 or something. You wouldn't want to say that. It's about 75. Okay. Any question on that one? All right. So the last thing is about triangles. And does anybody know when you have a triangle like this, it has 3 angles in it, and all 3 of these angles added together equal something? Does anybody know what all 3 angles in a triangle add up to?
180.
Yep, they all add up to 180. So all the angles inside a triangle add up to 180. So when you are setting up an equation for a triangle, you want to set up something like this. That's the formula you want to set up. On each of these lines, you put the first angle, the second angle, and the third angle. If there's a letter in the angle, no problem. Just put exactly what you see for the 3 angles. Doesn't matter which one you put where. You just have to put all 3. So what is one of the angles in our triangle?
80.
80. Okay, so we did that one. Now you can't use 80 again. What's another angle? 44. Okay, so we got that one. And the third one? 2a. So this one we're going to be solving for a. So what we want to do is combine like terms. What are my like terms that I could add together in this equation?
80 and 44.
Yep. And anybody know what we get if we add 80 and 44 together? 124. 2a is going to stay right where it is. And the 180 stays right where it is. Okay. What would be your next step if you were trying to get a by itself? Yep. Subtract 124 from both sides. What happens when you do 124 minus 124? That's gone. What's still on the left side? Nothing happened to this yet. 2a. And now, if you want to use your calculator, you can do that. Or, yeah, you're going to get 56. Okay, if you're not sure how to type it in, you just 180 minus 124. That's it. 56. Okay, so is A 56? Right, we have to divide by 2. This angle is 56, because that's 2a, and we know what 2a is. But the question wasn't what's 2a, the question is what's a. So what's 56 divided by 2?
28.
28. Yep, so A is 28. The only reason we're able to figure that out is because bless you,
Thank you.
we know all the angles have to add up to 180. Okay. Let's look at the last question. Okay. This one is very similar to the one we just did. Let's see. Okay. So it says the diagram shows a triangle. So start with this. What always goes on the right side when you're
180.
doing a problem with the triangle and the angles? Yep, 180. Okay. What's going to go on the first line?
33.
33. Okay, second line?
P minus 6.
P minus 6. And third line?
2P.
2p. Okay, we're going to do exactly the same thing we did before. So 33 plus p minus 6 plus 2p. So I just got rid of the underlines. Any like terms that I can combine in that equation? Yeah.
The P minus 6 and the 2P.
Can you give me a single term? P minus 6 is 2 terms.
So the P,
The P, all right,
so, and the 2.
and the 2P.
Is that supposed to have a degree after that 6?
We can put the degree symbol after when we're all done.
Alright.
What's 1P plus 2P? 3P, so we got that part done. Are there any other like terms I can combine on the left? 33 and the minus 6. What's 33 minus 6? 27. And what's still on the right side? Yep, 180. Okay, we got 2 steps left to finish it up. What's my second to last step?
Subtract 27.
Yep, subtract 27. And what happens with 27 minus 27? That cancels. What's still on the left side?
3P.
That's still there. And what's 180 minus 27? Yep, 153. So is that our answer? 153?
No.
No, what do we got to do?
Uh,
Yeah, what are we going to divide by?
3.
By 3. And that does go in nicely. Does anybody know 153 divided by 3? 51. Yep. Okay. So that's a sample of some of the IXL and MCAS questions that you will see. If you get stuck on any of them, I can definitely help you out. Okay?